So good afternoon everybody, myself Acharya Vishvendra, and today I am going to discuss a worksheet on torque. So let's start with the worksheet. So here is the worksheet. We are being given a force at an angle of 37 degree with the x-axis, and the point of application of force is at a distance of 4 from the origin. So first question is we need to find the force. So taking the components, we can say that force is equal to this component will be 100 cos 37 I cap plus this component will be 100 sin 37 j cap. Cos 37 is 4 by 5, so that gives 80 I cap. Sin 37 is 3 by 5, it gives 60 j cap. So force here is 80 I cap plus 60 j cap. Next question is torque about origin, it is r cross f. So vector r is minus 4 I cap over here, so we can say that r is minus 4 0 0 as j and k component are 0 and 80 60 0. After solving this we get minus 240 I cap. Next question is magnitude of torque, so it is 240. Next is torque about x-axis, it is 0 as there is no I component in this. Similarly, magnitude of torque about x-axis, this is also 0. Similarly, torque about y-axis is also 0 because there is no j component over here, and the magnitude of torque is about y-axis is also 0. Next is we are being given a rod of length L, and it is hinged about the end O. Let us say this point is O. We need to find torque about O. So torque is magnitude of force into perpendicular distance. So you can see the force acting on it will be the mg, the weight of the rod. And if we find the distance of this from the line of action, the perpendicular distance will be L by 2 sin theta. So torque will be mg into L by 2 sin theta here. Next is graph of torque versus theta. It will be a sine curve which will be maximum at 90 degree, and maximum torque will be mg L by 2. Next is we need to find alpha. So torque is equal to I alpha, which means alpha is equal to torque by I. I will be ml square by 3 over here as it is about end of the rod. So after solving this we get alpha is 3g by 2l into sin theta. Next question is graph of alpha versus theta. So that will be a sine curve which will be maximum at 90 degree, and at 90 degree alpha will be 3g by 2l. Next is we need to find omega as a function of theta. Initially we assume that theta is 90. So we take alpha is 3g by 12 into sin theta. So omega into d omega by d theta will be 3g by 12 into sin theta. Here we can see that theta is decreasing. So since theta is decreasing, so d omega by d theta will be negative. So as to compensate for that, we take here negative sign. So in all the cases we take negative sign. So after calculations, integrating it from 0 to omega and this limit from 90 to theta, after solving we get omega as root 3g by L into cos theta, like here. Next question is we need to find omega at theta is equal to 0. Initially we assume that theta is 90. So in this equation substitute theta is equal to 0. So we get omega is equal to root 3g by L into cos theta, which will be root 3g by L. Next is we need to find centripetal acceleration as a function of theta, and the point here is x is equals to L by 2. So we know that centripetal acceleration is r omega square. R here is L by 2, omega square is 3g by L cos theta. So on solving this we get centripetal acceleration as 3g by 2 into cos theta. Next question is we need to find tangential acceleration as a function of theta, and the point here is x is equals to L by 2. So we know that tangential acceleration is r alpha. R is L by 2 here and alpha will be alpha. Alpha we have calculated at 3g by 2l into sin theta. So on solving this we get tangential acceleration as 3g by 4 into sin theta. Next we are being given a question on that there are certain forces which are acting tangentially on a circle, and there are three forces over here. We need to find the net force. So we take the components, this is x-axis, this is y-axis. So this force will be F cos 53I plus F sin 53J. Similarly, this force will be 3F cos 37I minus 3F sin 37J, and this force will be 2Fi. So after adding all the forces, we have finally, after solving this, that force is equal to 5F I cap minus fj cap. So this is the net force after adding all the vectors. Next is magnitude of the net force. So this is done by squaring the I cap term and the j cap term. So we have root 26f over here. Now next question is we need to find the net torque. So you can see that about the center, this force will produce a torque Fr. So for calculations of net torque, we can see that this force will produce torque Fr. Sense will be clockwise. This force 3 Fr and this force will 2 Fr. Taking clockwise sense as positive and anti-clockwise as negative, we have net torque as Fr plus 3 Fr minus 2 Fr, which sums out to be 2 Fr. So we can say that net torque about the of the forces will be 2 Fr in the clockwise sense as per the system of forces is concerned.